This is 1T, and today I'm going to teach you how to solve quadratic inequalities. So let's get started. So first of all, we'll start with a graph and use that graph to help us solve a quadratic inequality. Now this is the graphing method. There's another method where you use what's called test points, but we're not going to do that. We're going to use the graphing method. So first of all, you can see that I've graphed, or I have a graph, picture of the graph for the associated function f of x is equal to x squared plus 5x plus 4. So as you analyze the graph, you can use it to help you solve this inequality. So first of all, if you look at the fact that we have the equal symbol here, in other words, we want to know when this expression is either less than or equal to 0, or we want to know what x values cause this expression to be less than or equal to 0. So we do want to know when it's equal to 0. That'll be part of our solution, and so we want to include the points where the function crosses the x-axis, because that is where the function, or x squared plus 5x plus 4, has a value equal to 0 for those x values. So when x is 1 or negative 4, x squared plus 4 or 5x plus 4 equals 0, which is part of our solution. Now next we want to consider which functions of x cause this expression to be less than 0. Well, we're going to be less than 0 wherever the graph goes below the x-axis, because the function values, or the y values, are going to be negative. Or another way to say it is x squared plus 5x plus 4 will have a negative value when x goes from negative 4 to 1. So finally, we can use that information to draw to write our solution using interval notation. So negative 4 to negative 1. Notice we have square brackets because we're including negative 4 and negative 1 because that's where we're equal to 0, which is part of our solution. Let's move on to the next example. So here we want to know when x squared minus 6x plus 8 is greater than 0. So again, we have the corresponding function, and so we're going to look at its graph to determine the solution. So first of all, notice there is no equal symbol here. So we don't want to know when, or I should say, where we're equal to 0, or for whatever x values x squared minus 6x plus 8 equals 0, that won't be part of our solution because there's no equal sign here. So we're only interested in knowing when this expression is greater than 0. So let's go ahead and put in our points. So notice I'm using open circles because 2 and 4, that's where this expression equals 0, which we're not including in our solution. Now we know that this expression is greater than 0 where the function is above the x-axis. So that happens on either end, so to the left of 2 when x is 2 and to the right of when x equals 4. And so our solution is going to include all the x values where the function is positive, and so first of all, that would be from negative infinity to 2, and then we also have to include the values on the other side, 4 to infinity, and so that's our solution. So now let's move on and let's do some problems more like what you're going to see in your homework. So we have x squared minus x minus 20 is less than 0. So let's talk about the steps we're going to use here. So first of all, you always want to make sure that you have 0 on one side. In this case, we do. And in fact, for the 3 examples I'm going to do, we will have 0 on one side. But if it weren't on that side, you'd have to get 0 on one side by itself. So let's go ahead and go to the next step. So notice what I'm doing is I'm going to set the expression, the quadratic expression, equal to 0, and then I want to solve that expression to find what we call the critical values. So let's do that. We factor, set each factor equal to 0, and we get our two critical values. Next thing we're going to do is label a number line with the critical values and draw a sketch of the related quadratic function to determine your solution. So first of all, I just want to point out here that the critical values are the values of x that cause this function to equal 0. So let's go ahead and make a number line with the critical values on it. Now we're going to draw a sketch. Now first of all, notice I put open circles on the critical values because we don't include where we're equal to 0 in our answer because it doesn't have an equal symbol on the inequality. It's strictly less than 0. X squared minus x minus 20 is less than 0. So we're not including negative 4 and 5, which make us equal to 0. So what we want to do at this point is draw a sketch of the related function f of x equals x squared minus x minus 20. Now this is a parabola that opens up because we have a positive coefficient here, it would be 1, and we know 2 points, really the x-intercepts where this quadratic function goes through. So let's go ahead and draw the graph, or the sketch. It would look something like that. So we know it opens up. We don't really need the vertex, although we could find it. So if we were to draw a sketch of f of x equals x squared minus x minus 20, it would look something like that. And we know it would go through the points negative 4 and 5. Now, if you look at the quadratic function, it says we want to know when x squared minus x minus 20 is less than 0. Well, that happens below the x-axis. So between negative 4 and 5, notice the function has values that are negative or less than 0. So finally, we're ready to write our solution. So we're going to write the solution using interval notation. And so it would be the points or the values of x between negative 4 and 5. Notice I'm not including the endpoints because our inequality does not include the equal symbol. Alright, let's move on to the next example. So we have 2x squared minus 5x plus 2 greater or equal to 0. So we're going to set that equal to 0. We're going to have to factor this using, now we're using the AC method. You can factor this however you want. So I'll just use the AC method off to the right over here. So we're multiplying 2 times 2, the a and c, to get 4. We're looking for two numbers that multiply to 4 and add to negative 5. The numbers that work are negative 1 and negative 4. So we're going to replace negative 5x using these two numbers. So we'll use minus 1x minus 4x, and then now it's just a matter of factoring this by grouping. So no matter which way you're factoring, you end up with 2x minus 1 times x minus 2. So let's go ahead and put that in on the left here. And of course we need to find our critical values. So set each of your factors equal to 0 and solve for x. So next thing we'll do is we'll put those critical values on a number line. And now remember, we're going to graph the corresponding quadratic function f of x equals 2x squared minus 5x plus 2. Again, we have a positive coefficient of x squared, so this graph is going to open up. The other thing is, notice we do have an equal symbol here. We want to know when this expression equals 0 or is greater than 0. And so I am using a solid dot. And again, we know it opens up, so it's going to look something like that if we were to sketch it on this number line. So we want to know when 2x squared minus 5x plus 2 is greater than 0. Well, that's going to happen when the function's positive, which occurs on the outsides here. And so our solution is going to start at negative infinity if we go from left to right. Then we get to a half. So the function has positive values from negative infinity until we get to x equals a half. And then on the right side, it goes from 2 to infinity. And so again, so now let's make sure we understand what this means. If you pick a number that's smaller than a half and you plug it in, this expression will be greater than 0. If you plug in a number that's greater than 2 into this expression, 2x squared minus 5x plus 2, you're going to get something that's greater than 0. Of course, when we're equal to a half or 2, this expression is equal to 0, and that's also part of our solution. All right, let's look at one last example. So x squared minus 3x minus 54 is less than or equal to 0. We'll set it equal to 0. Set our factors equal to 0. We get our two critical values. Put those on a number line. Now again, notice here it's less than or equal to 0. We want to know when the expression x squared minus 3x minus 54 is either less than or equal to 0. So we do have the equal symbol, so we are going to include our critical values. And then again, you can see that the coefficient of x squared here is 1, which is positive. So our sketch would look again like what we've been drawing so far, and all the problems we're going to be doing are going to be with positive x squared. And then we want to know where this expression is less than 0. That's when the function is negative. And so our solution will include everything from negative 6 to 9, including the endpoints. And that's it for this lesson.